So, welcome to the next session at the Virtual Battery Exhibition. The next session is from KROENERT, and it's about high-efficient electrode and separator membrane production for lithium-ion batteries as a basic for efficient energy storage system. And Frau Glawe is going to give you an overview over that. Just want to let you know that you are feel free to ask questions through the window questions in your control panel. And we're going to answer that question at the end of the presentation. And the presentation will be recorded, this session, and it will be afterwards finding it in your dashboard in Expo IP at the virtual exhibition login from your side. It's approximately 1 or 2 hours later available. And now I give the word to Mrs. Glawe and enjoy the presentation.
Yeah, thank you very much, Michelle, for the nice introduction. Good afternoon, everybody. I'm really pleased to give you in the next 20 minutes some information about the company KROENERT, about our activity in the battery business. I hope you all stay healthy. We had already a very amazing morning with more than 30 visitors at our virtual booth. It was really a lovely experience. So I want to give you a short overview about the demands for the electrode and separators. I want to show you coating systems which we are using, and I will introduce you some drying technologies, and I will show you also some machinery layouts. So at least when we look into batteries, for sure, we are more looking into the high efficiency batteries, which are used for electromobility. You see a very nice picture here from Hamburg, where the city is installing electrical driven buses. You see energy storage systems, which are necessary to store the energy of wind turbines or even from solar stations. And this is what is in our focus when we are looking into the battery business. So KROENERT itself, we are doing equipment for the anode coating, which is usually an aluminum foil with the functional layer on it. We do the cathode, which is usually a copper foil with the functional layer on it. And we are also in the business of the separator membrane, which is in between the cathode and the anode. So from the cathode side, usually aluminum foils are used. We handled already very thin films up to 8 micrometer, so very sensitive materials. The usual solid content of such chemical solutions is in between 40 to 70%. Viscosity 1,500, 6,000. More important is that usually these materials are thixotropic, which means they are changing the viscosity or shear thinning related to shear force, and this you need to evaluate when you handle such systems. Dry coat weight usually between 100 and 400 GSM, depending on the kind of the battery. When we go to the anode, it's usually a copper foil, so a more sensitive material. Also, it's quite thin, much thinner than the aluminum foil. So we handled already 6 micrometer thin foils, which is very sensitive material. And here also NMP, NEP, or even water is used for the binding of the chemical solution. The solid content is probably a little bit lower. And also the viscosity is in the same range than for the cathode. When we go to the ceramic separator membrane, it's here we handled one project with the company Brückner. Brückner is supplying extrusion lines for semi-permeable PE membranes, which are more and more used for this separator. And here we handled together a development project to coat the ceramic layer on both sides of this ceramic separator. And this material is more and more used because it gives a higher safety for the battery due to the very good heat performance of such materials. When we go into the coating process, which is for sure the focus of the presentation to show you which technologies can be used, We are always looking into processes where we need to guarantee to coat without any effect, without any defect, because it's very important to have a very even and uniform layer. Each tiny little failure will increase will change the quality of the battery, and this for sure is not in the interest of the supplier of such batteries. So we are looking into cross-web distribution, which is less than 1%. So it's a very high accuracy request. Wet film thickness can be very thin, but in the battery business, for sure, we are looking more into thick layer, which are usually in between 200 and 400 micrometers, so much thicker. And what we need to guarantee, the whole process needs to be stable over 24 hours without any failure, without any problem. When we are looking into battery systems or into coating layers for batteries, there are usually two different systems used. In many cases, these are intermittent slot die technologies, or even coma coating is realized. The highest performance, what you will see, is really slot die technology. The advantage of such slot die technology is that you can have it in a full range cover, so you can really adapt the system that you coat a closed layer without any stop. It's also possible with a special shim system inside the die to coat stripes. This is also quite reasonable. Mainly if you go to a wider working with such intermittent coating technology, which you will see here on the short movie, will not work anymore. In that case, as soon as you go wider than 500 millimeter, 600 millimeter working with, we always explain or offer the stripe technology for such a design. And as soon as you go to a smaller working with, such intermittent coating systems can be realized with a special design of the slot die. We at KROENERT, we developed together with the company TSE. TSE is a slot die supplier in Switzerland, very leading supplier for precise slot die technology. With them together, we developed a very special die, which is patented. And this die is handling the intermittent process different to the already existing systems on the market. So here we thought how to improve the process. The situation is, as soon as you have a valve technology where you do the start and stop operation, the valve is always in front of the die, which means the way from the valve through the die up to the area where you transfer the material to the substrate is very long. And we learned already that battery slurries are thixotropic, so they are really acting very sensitive to shear force, and due to that long way, it can be happen that the accuracy of the intermitting process is not good enough. And due to that, we developed a system where we have a oscillating rod inside the center of the die. This rod has a slit in the middle, and depending on the position of the slit, the slurry is going directly out of the die, which you see here, or it's going into a bypass and then back into the container. And with that, we can really very precise do such a start and stop operation, which you see here in the diagram, which is requested for high performance batteries. I already explained that we have a special intermittent die with the bar in the center, but we have also a valve technology. So, and we also followed that valve technology due to some reason for very critical slurries, which have, due to the particle size, trend to agglomerate. In this case, the rotation rod inside the die is causing some problems. And in such a case, we also introduce our customer to the valve technology. So at least both techniques can be used depending on the parameters of the slurry, depending on viscosity, and even depending on the speed of the machine, and for sure the working with. All this has an influence. And when we discuss with our customer what is the best technique in order to realize the request which is necessary for the special application. Here you have some parameters, how good we can realize such slot die technology. So the gap adjustment between the die and the substrate, which means here this tiny little gap, is in an accuracy plus minus 1 micrometer. The running precision of the opposite roller is also very important because this is also influencing for sure the gap in between the die and the substrate. This is also running in 1 micrometer. And we also need to look in the precise tension and speed adjustment, because as soon as you are running the web not in a constant speed, you will have a variation in coating thickness. This is quite difficult if this is happen. So we reached some parameters where we did some tests with a standard NMC material, PVDF binder, and carbon powder in the given parameters. And here we can really guarantee to reach the parameters which you will see here. So coating weight variation plus minus 1%, which is quite good. Also the coating thickness accuracy plus minus 1%. What is also very important for a battery product, you have on each side, you coat the active material, and with both sides needs to come really edge to edge together. So they need to be at the same position. This is realized with special alignment of the substrate, also with sensor systems. And here we can give a guarantee from 0.2 millimeter from one side to the other side. Accuracy in start and stop operation with the die during intermittent coating plus minus 0.6 millimeter, and also the accuracy of this we can give in a very good range, as you see here. Alternatively, for more thicker coating layers and also more higher viscous materials, we can also go to an intermittent or self-metered comma bar technology. This we can do in 2 operation modes, which you see here. So you can have a direct adjustment of the comma bar in gap to the roller, which is a direct process, but we also handle a so-called indirect process. In that case, you have a roller, which you see here, and you adapt or you adjust the distance between the comma bar and the roller, and then the roller is supplying the chemistry to the substrate. All this is possible depending on the application, really very good adjustable. When we go into the separator coating process, here at least are 2 different systems used. Slot die, even here are slot die technology used because you can coat very precisely the ceramic layer on top of the very thin separator membrane. Or alternatively, in this case, also Glawe roller systems are used in a so-called kiss coating mode, which you see here. So the substrate is only touching the Glawe roller on a very short or in a very short line, and there's no opposite roller, and due to that it's called kiss coating mode. Also here, both systems have a certain kind of range of applications, and this is usually depending on the particles in the ceramic slurry. So you can imagine you have aluminum oxide in a slurry, and depending on the size of the particles, the material is more or less abrasive. And in a slot die, the system is much better because you don't have that much abrasion in between the coating equipment and the slurry. In a Glawe roller, we heard from the market that a customer needs to change the roller each 1 week, and this for sure is a very expensive process. So here we can offer both technologies, and we tested all this in our technology center, and we can really discuss about that technology together with you. When we look into the drying process, to dry a battery coating layer, it's a very sensitive process because you have a very thick layer and you need to avoid to dry too fast in order to avoid that the surface starts to crack. And here, for sure, we can handle lab equipment, which you see here, drying equipment in 500 millimeter working with, or we can handle also drying equipment for working with in between 1 meter and even wider. For the small lab equipment, we go into a dryer system where we have a certain kind of door in front at the operator side, because it's quite easy to handle the dryer from that one side. As soon as we go in a wider working with, we have a completely lifting system so that the dryer is opened in a completely parallel lifting, and then it's quite easy to reach all the nozzles for cleaning or maintenance performance or whatever is necessary to handle the dryer. With dryer, we can operate for sure in an explosion-proof range under standard atmosphere, so no special atmosphere in the dryer, but we also can handle such a dryer in inert atmosphere. It's quite often used to minimize the oxygen content in case a solvent recovery system have to be installed. In that case, you have already the oxygen out. And the second advantage is when you have an inert clean dryer, you can go much higher with the solvent concentration in the air of the dryer, and with that you can much better control the drying process, because you can play in the first drying zones with a certain kind of overloading of solvents, and with that you can avoid that the solvents are evaporating too fast, and with that the film formation during the drying process is much better. We can handle flotation dryer, we can handle support-driven roller dryer. This is usually depending on the length of the dryer and also for sure on the process, double-side coating, single-side coating. Here you see such a machinery layout with solvent recovery. So all the drying zones are connected to the condensation station and to all the equipment which is necessary to distillate or to concentrate the solvents out of the air. So finally, I want to show you some machinery layouts which were already realized and which are running at the market. This is a machinery laid out in 500 millimeter working with. You see here the winding station, the coating area, which is for sure completely closed because there are solvents handled, and it's necessary to control the solvent evaporated air. Then we have the drying equipment. In this case, we installed a 10-meter long dryer, and at the end, the finished substrate is rewinded at the rewinding station. So here you see such a coating line from the side view with all the equipment, the winding station, coating area, dryer, and rewinding of the finished material. For sure, for certain applications, also large coating lines are installed. So here we handled already equipment wider than 1 meter working with. And as soon as it's going in a wider range, the typical layout is that the winding station is in the first level of the machine. The coating area is usually on that position, and then the substrate is going in the second area or in the second level for handling the drying process. And this can be really adapted to the installation area. This was a machine where the dryer was in the second level of the building. So the complete machine for coating material handling was in the lower level, and in the second level was the installation of the dryer. So here are some typical layouts. It can be for single side coating, or if the coating should be realized both layers in one run through the machine, we have 2 coating stations and 2 dryer in the machine to handle the complete material in one run through the line. Typical separator machine, for sure there's only one coating head installed, due to the very thin membrane we're handling is a little bit more critical and needs to be more better controlled. So thank you very much. If you need more information, you will be highly welcome to visit us at our virtual booth. And I want to finish with that nice view of an electrical driven bus in front of the Elbphilharmonie in the city of Hamburg. Thank you very much for your attention. So
thank you very much, Ms. Glawe. We have a lot of questions, so I hope we can get a few of that done. The first question is, do you also coating of slurry via a gravure printing technology?
Yes, we do it, but usually the layers which are necessary for batteries are too thick for a gravure roller design. If the thickness is not that high or the request for the thickness is not that high, then it can be also realized with gravure roller. But
Okay,
usually you are going to 200, 300 GSM for a battery electrode, and that is too much for gravure roller.
Okay, thank you. Next question is, how do you control top to bottom coating?
The thickness by the coating equipment. Wow. Yeah, at least you have two precise coating heads, and these both are controlled in the same way. Depending on the process, for the primer, we often do a really simultaneous double-side coating. For the battery itself, there are really two separated processes, and in between you can have a thickness measurement system to control the thickness, and depending on the result, you can have a direct adaptation of the pumping speed of the die for the die.
Okay, thank you. The next question is, how do you measure the quality of the coating in terms of edges, width and length, intermittent only?
Usually we are using thickness measurement system by laser triangulation. And in addition, we quite often install also a vision system where you can also control very precisely the design of the intermittent coating, and also the quality of the layer itself, if you have cracking or pinholes or whatever in your layer. So at least there are thickness measurement systems used as well as vision systems.
Okay, thank you. How much waste do you need to get to top to bottom in position? I think that's the way he corrects the question from the first top to bottom coating. I think he means top to bottom in position.
Usually, as soon as you have a good operator team and you understand the process in a very good way, you have no waste. So it's completely controlled technology, and as soon as the die is running, there's no waste coming out of the machine. For sure, when you have an winding roller change, we always recommend to have a fully automated turret roller winding change system. In that case, you have a certain kind of waste at the beginning and at the end of each roll, but this is not that much.
Okay, thank you. The next question is, what kind of inert gas is used inside the drying process and what cleanliness is requested?
Usually is nitrogen used for that process, and the cleanliness should be really nearly 99.9%. So you really need to avoid to get moisture in the system, because you are getting already moisture with the coating layer, and if you have a lot of moisture or water in the evaporated solvent, you need to take this water out, because at the end you need, or you want to have a very highly concentrated solvent, and as less water is in the solvent from the really beginning, how better is the cleanliness of your solvent. So high purity of the nitrogen should be chosen.
Okay, thank you. I think we have time for one last question, and then we're going to end the session. The last question is, how do you control the intermediate coding in terms of the coding length as well as the position from the top to bottom?
The intermittent length, it's only a software system, so we control, or the customer can adapt in the software how long the intermitting process should be realized. So really you can adapt that in millimeter. And from one side to the other side, we control it with a sensor. So there's really a detection sensor, which is watching the coated area, and then the die from the bottom side can really code at the same position in a precise way.
Okay, thanks a lot, Mrs. Glawe. Can you provide your email address to the audience? Can I give it to the audience?
Yeah. I can also type it. When I type it, is everybody seeing it, or?
I can forward to everyone. Wait, I have it here, and I'm like copy pasting it.
Yeah,
right
sure.
here, and send it to all so that everybody has the contact details from you and can contact you
Yes.
afterwards, because we have a few more questions but no time left. I thank you for this interesting lecture, and you feel free to visit KROENERT at the booth and get in touch with the specialists there. And we see you at the next session at 2:30. So see you soon, and bye.
Yeah, bye-bye, and all the
Bye-bye.
best to everybody. Stay healthy. Bye-bye.
Thanks. Bye.